Hello friends. Theorems. I never understood why people are so much afraid about this word. Theorems are nothing but a given statement which we have to prove with the given information and by applying logic and math to it. Today, I am going to break the myth that theorems are difficult and very tough to understand. In this session of circles, we are going to deal with 12 theorems, 2 minutes for each theorem, maybe a minute up or down. So, before we actually move to theorems, we will go through some facts, some basic concepts which we will be using in the theorems to prove them. So, let's start with basic concepts and terms related to a circle itself. Well, we can see in this chart a circle has a radius, diameter, sector, segment, chord, secant and arc. We will be using these terms very frequently in this session, so please do understand the meaning of each term. Next, we are going to see some basic properties about triangles, majorly how to prove two triangles congruent. Again, we have a chart in front of us. This chart shows us some criteria that we are going to use to prove triangles congruent. Now, you must be thinking why suddenly we are talking about triangles during a session related to circles. Don't worry, you will come to know about it as soon as we reach to our first theorem itself. And some extra reminders like angles in a triangle add to 180 degree and pair of linear angles are also 180 degree. And one last thing before we start the theorem. The addition of the remote interior angles of the triangle is equal to the exterior angle. Believe me, if you understood the first 2 minutes, the rest of the things are going to flow as smooth as water. You can pause this video at any minute you want because it may go a little fast for some of the viewers, and if you want to go through the first 2 minutes again, if you feel like, before we move to the theorems. Let's move to the first theorem. Equal chords of a circle tend equal angles at the center. So, according to the statement, we have two chords AB and CD. We have to prove that angle AOB is equal to angle COD. Now, as we can see, if we can prove that both the triangles are congruent, then we can say that both the angles are also congruent. So, if we have a look in triangle AOB and triangle COD, AO is equal to OC and BO is equal to OD because they all are radii of the same circle, and AB is equal to CD because we are given that both the chords are equal. Now, as we can see, we have three sides which are congruent. So, by using SSS test of congruency, you can say that both the triangles are congruent. Now, if the triangles are congruent, which means that they are equal in all the aspects, so we can say that angle AOB is equal to angle COD, which is nothing but a corresponding angle of congruent triangle. Now, let's see the converse of this theorem. If the angles subtended by the chords of a circle at the center are equal, then the chords are also equal. Again, we can have a look at the same diagram. Now, it's given that both the angles are congruent, and now we have to prove that the chords are also congruent. Again, we have the same triangles where AO is equal to OC and BO is equal to OD because they are the radii of the same circle. But now, angle AOB is equal to angle COD. So, what do you think? Using which criteria we can say that both the triangles are congruent? Yes, you are right. Using SAS criteria of congruency. Now, since the triangles are congruent, we can say that chord AB is equal to chord CD, which is nothing but a corresponding side of congruent triangle. Let's move to the third theorem. The perpendicular from the center of the circle to a chord bisects the chord. So, as per the statement, we have a chord BC and a perpendicular from the center A on the chord BC. Let's name the point as D. So, AD is perpendicular to BC. Here we can see two triangles, triangle ADB and triangle ADC. In these triangles, AD is equals to AD because it's just a common side in both the triangles. And AB is equal to AC because it's the radii of the same circle. And we have angle ADB is equal to angle ADC and both are equal to 90 degrees. Since we are given that AD is perpendicular to BC. So from this we can say that both the triangles are congruent by RHS criteria of congruency. Now since both the triangles are congruent, BD is equal to DC. Now since BD is equal to DC, we can say that BD is the midpoint of chord BC. Hence we can say that AD is the perpendicular bisector of chord BC. Let's move to the fourth theorem. I believe it's going easy so far. The line drawn through the center of the circle to bisect a chord is perpendicular to the chord. We know now that if we want to prove a converse of the previous theorem, then we have to prove that the segment AD is perpendicular to BC. If we see in the same circle again, if we prove that angle ADB is equal to angle ADC, then we can prove that AD is perpendicular to BC. We again have same triangles, triangle ADB and triangle ADC. We know AD is equal to AD and AB is equal to AC, same like previous theorem. And BD is equal to DC because it's given to us now. So, both the triangles are congruent now by SSS test of congruency. Now, we can say that angle ADB is equal to angle ADC. But from this, we cannot say that both the angles are 90 degrees. But we know that angle ADB plus angle ADC should be equal to 180 degree because both are supplementary angles, or we can say linear pair of angles. Now, from 1 and 2 we can say that angle ADB plus angle ADB is equal to 180 degree, and hence we can say that angle ADB is equal to 90 degree, which is equal to angle ADC. So, we have proved that AD is perpendicular to BC. Here we are done with 4 theorems. I hope you all are with me. If it is going fast, you can stop the video at any second and revise the things. Let's take an easier one this time and a little different one. There is one and only one circle passing through 3 given non-collinear points. We will prove this using few geometric constructions. Let's take 3 different points, let's say A, B and C. Now we will join them. Now in order to draw a circle, we need a center which will be equidistant from all the 3 points, and there is one more thing that we need to draw a circle. Yes, a radius. So, if we draw perpendicular bisectors on both the segments, that is AB and BC, we can see that both the perpendicular bisectors meet at a common point. Let's name it as O. If we consider this as the center and draw a circle considering AO or BO or OC as a radius, we can see that we are having a circle which is passing through point A, point B and point C. You can try this on paper taking any 3 non-collinear points and make a circle passing through them. Well, we have just completed another theorem by doing this activity. I hope we are going well so far. See you in the next session where we will use these theorems to prove further more theorems of circles. Till then, keep watching, keep learning. And yes, don't forget to like, comment and subscribe. Thank you.